Welcome everybody to our Unit 4, or whatever unit this is going to be, introduction about quadratics. We're going to do a lot of different things with quadratics. We're going to learn how to solve quadratics 4 different ways. That's these right in here. We're also going to take a little bit of a kind of a sideshow right in there for that computations thing as we go along. But after that, then we're going to kind of do some applications with those 3 targets. We got circles, graphing quadratics, and solving linear quadratic systems of equations. And just thinking ahead to circles, it's obvious that if you're talking about circles, the best shape to use is obviously a triangle. We'll talk about that later. We're going to start here, quad 1, solving quadratics using the square root principle. Let me give you kind of an introduction of everything. Introduction to quadratics. We have quadratic form or standard quadratic form. We're going to call that ax squared plus bx plus c. Quadratics deals with squares. In this case, we're dealing with an x squared. Now, fortunately for us, there's more than one way to solve a quadratic. We have when we're saying solve, what we're trying to do is find zeros or roots, and when we say solve zeros or roots, usually, and again, foreshadowing here, usually that means where the function crosses the x-axis or where y is 0 or where y equals 0. Sometimes that equation just doesn't cross the x-axis. And if that happens, what we have is just like my friends, and this is known as imaginary solutions. Imaginary solutions. So with this knowledge that we have, we're going to take a look at our first main topic. And our first topic is one of the solving topics, solving quadratics using the square root principle. All right. Oh, there we go. Let's go back to the top here. Like I just told you, full form of a quadratic, ax squared plus bx plus c. Usually what we like to do is put a y equals with that. We're going to go ahead, y equals ax squared plus bx plus c. Now, we know the opposite or the inverse operation. I don't like opposite. Let's go with inverse operation. When I say inverse operation, we're thinking of undoing, right? So the inverse operation to multiplication is division. The inverse operation to subtraction is addition. The inverse operation to squaring is to take the square root. Yeah, there we go. Square root. Just got excited there. The inverse operation of squaring is taking the square root. If we want to only use square roots to solve, we have to have it in a very specific way. We call this vertex form. You've actually seen it before when we did some graphing of functions kind of at the beginning of the year. What it looks like, this vertex form is y equals a times x minus h squared plus k. That k, that's your vertical translation. That h is your left and the right. And the a is your vertical stretch or compression. We're not dealing with horizontal stretch or compression here. And we'll see why in several targets. So it looks really nice to do that because all we're trying to do is we're going to isolate a perfect square and then solve. So in some cases, after we've taken the square root and simplified the square roots, we've talked about that already, you might have to add or subtract a value to solve, but you know how to do that. You've done that a million times up to this point in your math career. One way for you to know if this is possible to solve using by square roots, if you don't have any plain x terms. So if you've got like an x squared or x with something squared, you're fine. But if it's like x squared plus 3x plus 4, you can't use it this way yet. Yeah, we'll talk about that in a different target down the way. Let's go ahead and formalize something. So if x squared equals c, then x equals plus or minus the square root of c. And don't forget the plus and minus. And you're saying, Mr. Brayman, why is it plus and minus? And I'll say to you this: what squared gives you 9? And I know the first thing you're going to say is, well, 3 squared gives you 9. And to that I say, yes, what else? And then you'll sit there and think. There's nobody in the room right now, but that's what happens usually. And then when brave soul speaks up and goes, what about -3? And yes, that would be it. So -3 times -3 is a positive 9, and 3 times 3 is a positive 9. So what happens is we have 2 solutions most of the time. So don't forget the plus and minus the square root of c. I've got 4 steps. Here's kind of the algorithm for solving this thing. The first one is just like we've done a ton of times. We're going to isolate the perfect square. Isolate the perfect square. Whoops. And what does that look like? I'm glad you asked. In other words, it's going to be either x squared equals a number, or that x minus h squared equals a number. And that means we're going to get rid of the h and the a part, or sorry, the k and the a, if you remember what I talked about with vertex form just a minute ago. That's our first one. The second one, and we're going to do the inverse operation. We're going to take the square root of both sides of the equal sign. Take the square root of both sides. Taking the square root of the both sides of the equal sign. This is where you don't forget that plus and minus. We'll star, don't forget the plus and minus. Now I'll just take the stars out so you don't get a little confused there. Don't forget that plus and minus. And then we're going to do the thing we've done already in a skill fashion. We're going to simplify the radical. And I'm going to remind you of what that is as we go through some of these practice here. Simplify the radical. Simplify the radical. That means what's under the square root will simplify. And then we have a last step. We're going to solve for x, or whatever variable we're using. Solve for x. Solve for x. And I'm going to throw this in here. If necessary. Because sometimes after you've done step 3, it's already solved. If you get it, if it's just x squared equals a number, it's already solved. If it's x squared minus a number or plus a number, then squared, then we'll have to do one more step. All right, let's see what that looks like in action. All right, as we turn to page 3, keep those 4 steps in mind, or 3 with a 3 required steps and 1 maybe step in mind. Our first step and our first example, the first thing that we have to do is isolate the perfect square. In this case, that is x squared. I want to have x squared equals some number. Do not convert these to decimals. I'm going to divide both sides by 3 to get x squared equals 32 divided by 3. That is step 1. We have isolated the perfect square. Step 2 is to take the square root of both sides. And when we do that, we end up with x equals, don't forget the plus and minus, the square root of 32 divided by 3. That's our step 2. We've taken the square root of both sides. We did not forget our plus and minus. Now, the next step comes from our skill building that we've been doing. We have to simplify 32 thirds. Well, it doesn't simplify like that. Don't turn it into a mixed number. Don't turn it into a decimal. We're trying to keep this as an exact solution. If you remember back, if you've got a fraction that's in a square root, you can actually simplify that. Oops, I almost got to go ahead of myself. You can simplify that by taking the square root of the numerator divided by the square root of the denominator. And then we start looking for perfect squares. Well, square root of 3, we just can't do anything with. That's done there. But 32 is interesting. 32 has a perfect square in a product other than 1, and that would be 16. What if I turn the square root of 32? Remember, the square root of 32 is not 32. Square root of 32, what if I turn that into root 16 times the square root of 2? What do we know? We know that the square root of 16 is 4. This gives us plus or minus 4 times the square root of 2 divided by the square root of 3. And almost done. Almost done. What we don't like in this case right now, what the last thing we have to do is rationalize the denominator. We don't like square roots in the denominator, so we're going to multiply the numerator and denominator by a fancy version of 1. And what's that fancy version of 1 look like? Square root of 3 divided by the square root of 3. Because if I multiply something by 1, it doesn't change, and that's beautiful. But what happens here? Square root of 3 squared, remember, those undo each other, squares and square roots, inverse operations. My denominator is just 3. My numerator, I've got the 4 in here. Don't forget plus and minus, Mr. Brayman. Plus and minus, my 4 does not change. And then I group my root 2 times root 3 into root 6. My full answer is x equals plus or minus 4 root 6 divided by 3. That pretty much right there sums up everything that we've had to do up to this point. The only thing we don't have to do is step 4 because it's not necessary. X is already solved for. It's already solved for. That was a lot of work to get through that. Okay, let's go ahead and do one more example together before I let you try one. Example 2 says 3 times x plus 7, that quantity squared, minus 2 equals 22. Well, our perfect square in this case is this x plus 7 squared. So what I want to have before I start taking square roots is x plus 7 squared equals some number. And how do I do that? We treat it like two-step equations. That's all we got to do, right? We're going to add 2 to both sides of the equation. X plus 7 squared equals 24. We're going to divide by 3 to get x plus 7 squared equals 8. Is the perfect square isolated? Is this something squared? Only something squared equals a number, and the answer is yes. We have isolated our perfect square. Well, step 2 tells us we have to take the square root of both sides without forgetting plus and minus. Don't forget, don't forget, don't forget. Plus or minus the square root of 8. And let's see. Step 3 tells us we need to simplify the radical if we can. Is there a perfect square in the square root of 8 that's not 1 when we talk about products? And hopefully you're seeing this already, right? 4 is a perfect square, and 4 times 2 gives me 8. This could be plus or minus the square root of 4 times the square root of 2, because that's still square root of 8, but we know the square root of 4. So we've simplified it. We can get x plus 7 equals plus or minus 2 square root of 2. That's the radical has been simplified, but this is an example where we have to solve for x. We have to do a step 4 because it's not x equals, it's x plus 7 equals, and that's not what we're trying to do. We're going to subtract both sides by 7, and we're going to get x equals, watch where I put this, negative 7 plus or minus 2 square root of 2. This is the final answer. And here's what this, just as a reminder, here's what this means. This means I have 2 solutions. One of the solutions is negative 7 plus 2 times the square root of 2, while the other solution is negative 7 minus 2 times the square root of 2. That's what that means. That's what the plus and minus means. All right, you've seen a couple examples. Notice how those aren't negative numbers in there yet. So what I want you guys to do right now is to go ahead and pause it, or whatever system you're on, take a minute to try number 3, example 3, on your own. Then come back when you're done. Welcome back. Hopefully this is what you ended up with. When we isolate, we'd first subtract 2, then divide by 2 to get x minus 5 squared equals 36. Take the square root of both sides, so x minus 5 equals plus or minus the square root of 36. We know the square root of 36. That's a perfect square. That's just 6. Notice how there's no square root anymore in 3, right? Because the square root of 36 is just 6. We can get rid of the square root. It's already been used. And then this is where this one gets interesting. So I maybe hoped you saw this here. I would add 5 to both sides. I have 5 plus or minus 6. When you can, do. In other words, when you can add whole numbers together, go ahead and do that thing. We can do 5 plus 6, which is 11. We could also do 5 minus 6, which is negative 1. All right, those are the 3 examples we're going to try to do for this one. This is what happens when we've isolated the perfect square and you end up with a positive number, something like x squared equals positive 6 or something like that. We also have the case when things get a little weird, when that's a negative number, because we have the imaginary interlude. And up to this point in your career, mathematically, when you got the square or something squared equals a negative number, or trying to take the square root of a negative number, you get no real solutions, which is absolutely true. You do get no real solutions. What you actually get is imaginary solutions. And imaginary solutions are kind of interesting because we're going to use this imaginary unit. Imaginary unit. You can blame the Italians for this. The imaginary unit we're going to call I, and I is the square root of negative 1. I is the square root of negative 1. Or, I mean, conversely, in the same. The square root of negative 1 is I. So, with that said, we have a couple properties I'm going to introduce to you now. I want you to just take them and put them in your back pocket or your kind of math toolbox, if you will. We'll use that later. But what I want you guys to know, we've got I, which is the square root of negative 1. I squared is negative 1. I cubed is negative square root negative 1. And I to the 4th is 1. Now, just so we're on the same page, the 2 that are most useful for you right now are these 2. These are going to be useful for you. Useful for you. Those other ones, not as useful. Not quite as useful. Not for us right now. They can be useful for other applications, but not for us right now. What we have now is the opportunity to use these. So instead of getting the square root of a negative number and just saying no real solutions, we're going to have solutions that are just going to be imaginary. I know it sounds weird for me to say that out loud too, but we're going to have imaginary solutions. Let's see what that looks like in some examples. All our other rules still apply, but I've got 2 times x minus 4 squared equals negative 16. We still need to isolate the perfect square. In other words, we need to have x minus 4 squared equals a number. Just in this case, it's going to be negative. I have x minus 4 squared equals negative 8 because I've divided both sides by 2. It is isolated. Step 2 tells us to take the square roots of both sides of the equal sign. And we do that to get x minus 4 equals plus or minus the square root of negative 8. At this point before, you would have said, I'm done, no real solutions. But this is algebra 2. We're going to have some solutions. They're just imaginary. Now, this is the point when you see that negative number inside of the square root, we pull that out and call it an I so we can simplify the rest of the square root. We have x minus 4 equals plus or minus I square root of 8. And we need to simplify the square root of 8. To simplify the square root of 8, we do the same process. Square root of 8 is the square root of 4 times the square root of 2, which is just 2 root 2. But let's look to see where the I goes here. The I will go after whole numbers, after the 2, but before a radical, before a square root. In other words, what we have is x minus 4 is plus or minus 2i square root of 2. The order matters. Make sure you've got the order correct. Make sure you have the order correct. Now, that was step 3. I know it's imaginary, but that's what it is. We do have to do a step 4 here because x has not been solved for. We need to add 4 to both sides, and we end up with x equals 4 plus or minus 2i square root of 2. This is real. This part is imaginary. We cannot combine real things with imaginary things, just like real life. All right. So we can't combine real and imaginary things. Those are my 2 solutions, and they just happen to be imaginary. I know it's weird. I know. It's going to be okay. Okay, I'm going to give you one more example before I let you loose here on your own. I still need to isolate. I'm still going to subtract 8 and then divide by 8. X squared equals, if I subtract 8, that's negative 22. And if I divide by 8, that's like negative 22/8. And simplify when you can. Simplify when you can. They're both even. I'm going to divide them by 2, which is negative 11/4. So let's just kind of rewrite it. X squared equals negative 11/4. That's isolated. Step 2 tells me to take the square root of both sides. X equals plus or minus the square root of negative 11/4. I have a negative in the square root, so I have to bring the negative outside the square root and call it an I. So I have plus or minus I, and I'm going to do 2 steps. I'm also going to break that up in the whole quotient thing. Root 11, I root 11 divided by root 4. That's that quotient rule when it comes to radicals, sorry. And we look to see if we can simplify. I can simplify the square root of 4. The square root of 11, I cannot simplify because there's no perfect square other than 1 in the products that go to 11. So what you end up with is x equals plus or minus I root 11 divided by 2. And since there's no radicals in the denominator and nothing else can be simplified, that is our final answer for this one. Is it a lot? Absolutely. It's going to take practice. I promise you that if you put in good practice, if you make good attempts, and if you ask questions when things aren't going well, and you practice, it's going to come to you. I promise you that. Work hard. Let us help you out. The first one you're going to work hard on is this example 3. Go ahead, give it a shot, pause, or do whatever you need to do. Try it, and then come back and check your work. All right, let's go ahead and walk you through this last one here. To simplify, we will add 7 to both sides and then divide by 9 to get x plus 2 squared equals negative 37 divided by 9. That's our step 1 to isolate. Step 2 is to take the square root of both sides of the equal sign without forgetting the plus and minus. So I have x plus 2 equals plus or minus the square root of negative 37 divided by 9. When you have that negative in the square root, you know you have an I. Go ahead, pull that I out front. X plus 2 equals plus or minus I, and then use the quotient rule on your fraction. Root 37 divided by root 9. Well, root 37, that's nothing we can do with. That's just 1 and 37's prime number. But we've got that root 9, which is 3. The square root of 9 is 3. So I've got x plus 2 equals plus or minus I root 37 divided by 3. That's the most simplification I can do to that radical. But I haven't solved for x. So I need to finish by subtracting 2 from both sides. And I end up with x equals negative 2 plus or minus I root 37 divided by 3. As a reminder, the i's go before square roots, but after whole numbers if they exist. This is the end of kind of the introductory part. What needs to happen now is practice, and then practice and practice. And in that practice, you need to ask questions. Do what you got to do to make that happen. Practice, ask questions, make mistakes, fail now so you don't make mistakes later. Learn from those mistakes. Let me help you. Let us help you. Have the people around you help you. And we're going to get through this together. Hope you guys have a great day. Take care. We'll talk to you later.